This is our last example in the section 7.3 of our notes on page 8. Before, we've been using the trig identities to help us prove that certain trig equations are true. Now we're going to use it for a different sort of question where we're trying to find a solution to a trigonometric equation. So this equation is something you've kind of already seen before in the last lesson. But instead, now it's not consistent with the trig functions. We have cos and we have secant. For the most part, we like to see the same functions. And that means we can probably change this to a cos. And we know that secant is 1 over cos x. So let's make that change. So this will become 2 over cos x. Now my problem here, I have a fraction, and I don't really like fractions, so I'm going to get rid of that by multiplying both sides by cos x. Now I'll get rid of the fraction on one side, but then I have to multiply to the other side, and I'm multiplying to everything. So put that bracket in. Okay, so if I expand on this side here, that would be 3 cos x squared plus cos x, and then I'm just left with 2 on the other side. Now I'm going to move the 2 to one side so I can factor this, just like in the other problems we've seen before. And if I factor this properly, I should get 3 cos x minus 2 cos x plus 1. The first thing you want to do is rearrange it and factor. Second thing would be factor. Now we're going to solve each separately. 3 cos x minus 2 is 1 that I need to solve. And the other I need to solve is cos x plus 1 equals 0. So I'm trying to get cos x by itself. I'm going to move the 2 to the other side and then divide both sides by 3. Now if cos x is equal to 2 over 3, 2 over 3 is not one of our exact value triangles, so I have to use my calculator for this one to find its angle. The reference angle then will be cos inverse of 2 over 3. And plugging that into my calculator, I would get 0.84. Make sure that your calculator is in radians as you're doing this. Since cos is positive here, because it's 2 over 3, positive 2 over 3, I know it's in quadrant 1, and then I know it's in quadrant 4. In quadrant 1, we already found that, that's 0.84. But in quadrant 1 is 0.84, and then quadrant 4, it would be 2 pi minus our reference angle. And that gives us 5.44. So those are the two solutions so far on that one end, and now to calculate cos x plus 1 equals 0. I want to isolate my cos x. I'll move the plus 1 to the other side, so that's negative 1. This happens at pi, because our point here is negative 1, 0. And remember from our unit circle that our x-coordinate will give us the value for cos. So in this case, x is equal to pi. Now altogether, if you add both of them, x is 0.84, 5.44, and pi. And then we're done. The last question here. Now we have sine x plus root 3, cos x equals 0. Now there's a certain trick to do this because it's not quite obvious right now that I can change the sine x to cos x, or I can change the cos x to sine x. But what I can do is think about my tan x identity, and that is equal to sine x over cos x. Well, if I multiply both sides by 1 over cos x, I can probably manipulate it enough so that I can get one trigonometric function. So let's do that. So I'm just going to multiply both sides by 1 over cos x. Then I have sine x over cos x plus root 3. Remember, the cos x at the top will cancel the cos x at the bottom, so I'm left with just root 3. And then 0 times 1 over cos x is still 0. Well, now I can change sine x over cos x into tan x, and then rearrange it so that I'm solving for tan x is equal to negative root 3. So this is our rearranging part. Now the next thing I want to do is figure out what my reference angle would be. And this is actually coming from our exact value triangles. So I'm going to draw out my exact value triangle with pi over 3 and pi over 6. And we get root 3 for tan x when we have tan of pi over 3. Because tan of pi over 3 is opposite, which is root 3, over adjacent, which is 1. So a reference angle will be pi over 3. Next thing I want to do is look at what quadrants I belong in. So tan is negative in quadrants 2 and 4. So in quadrant 2, I would have 4 pi, I would have 2 pi over 3. And then in quadrant 4, that would be 5 pi over 3. And if we look at our domain, we want only from 0 to 2 pi. So then it's just those two angles and we're done. And we'll state that at the bottom, x is equal to 2 pi over 3 and 5 pi over 3. And then that's it.